unique is the fact that we're dealing with linear equations that have two variables. And so up until now, typically we've had equations that have just one letter, right? Either an X, an S, a P, or a T, any letter in there. Linear equations that have two variables, though, are an equation that has two variables. So it has an X and a Y. It has two things that we're solving for. Okay, and so I just put on here an X and a Y. Now keep in mind, technically you can have any sets of letters, but what we're going to do is associate X and Y because we're going to start graphing these as well. And when we have a coordinate system, we typically have an X and a Y axis. Okay? The problem with this is that most of you are used to having just one solution. In linear equations, there can be many solutions, and so we're not necessarily focusing on one particular answer on this, but yet a group of answers, okay, and a group of answers that makes the statement true. So keep in mind, with linear equations, you can have more than one answer, so kind of shift your brain from what we've just got done working with absolute value and inequalities and all that stuff where we have a certain number of solutions. Here we're going to have many, many solutions. So linear equations with two variables have solutions for both the X and the Y variables. They have an infinite number of solutions. And so here we're not going to write a single solution set, but rather a set of what's called ordered pairs. And remember, ordered pairs is what we're going to plot on the graph. They usually run in the X, Y in this format. Okay, and the key thing with these is both the X and the Y have to satisfy the equation. So we're making that statement true. Okay, go ahead and go to the next page, or the next, over here. Okay, so let's just do an example of this. So it says determine 5 ordered pair solutions for the equation. So this is your equation. You can see that it has both a y and an x. Those are the two variables. I've gone ahead and selected your 5 pair. If your homework says, determine 5 ordered pairs, pick a couple of negatives, pick a 0, pick a couple of positives. The easiest ones to do are -2 through +2. Now, on your homework you do have to show work. On a quiz, you have to show work. On a test, you have to show work. So what you're going to do is we're going to take these x values, okay, we're just going to plug them into our equation, we're going to solve for y, and then we're going to write an ordered pair because we have an x, we'll have a y, we can write it as an xy coordinate, okay? And so what I like to do is just rewrite the equation, but instead of x, here I'm going to substitute my -2 in, and then solve straight down. 3 times -2 is -6, minus 4, okay, -6 minus 4 is -10. And so this is my y value. Once I've plugged it in, I can write an xy coordinate pair as -2, -10. Okay, so your answer to this middle column here where your work is being shown, that's the y value that you get when you plug in the x value. Very, very simple. So the next one, we're going to substitute -1 in for x. So the same equation, 3 times -1 minus 4. Solve straight down. 3 times -1 is -3. Minus 4 is -7. So I've got two values. I've got my x, I've got my y. -1 comma -7 is my ordered pair. Very simple. Or at least it should be. If it's not, let me know and I can kind of rephrase things. Okay, we're going to do this for all 5 pairs. So, y equals 3 times, my x is 0, so I'm going to substitute that into the equation, minus 4. Now, 3 times 0 is obviously 0. Minus 4, my answer here will be -4. So my ordered pair is 0, -4. And all you're doing is substituting those values in for x. And let me know if I go too fast. I'll slow down. Okay, two more that we're going to do. Positive 1 and positive 2. Let me darken that up. Oh, I'm sorry. There, is that better? Okay. So, y equals 3 times 1 minus 4. Solve straight down. 3 times 1 is 3. Minus 4 is negative 1. Okay. So my ordered pair is 1, negative 1. Any questions so far? Is this pretty straightforward? All we're doing is plugging them in. So 3 times 2 minus 4. 6 minus 4 is 2. And so my ordered pair is 2, 2. And so here we've got 5 ordered pairs that satisfy this equation here. Now, could we have more than just 5? Yes. This is just a sampling of the ones that we took. We picked these, or I picked them actually for you. But you can see how this equation can have infinite number of solutions. Okay, I could put in negative 20. I could put in positive 60 and have a y value for that. Okie dokie. Go on to the next page. Any questions so far? Okay. Let's review the rectangular coordinate system. Now, I probably will never ask you on a quiz to name the quadrants, but I would like, if you have 2 map pencils or 2 highlighters, if you want to share with somebody, that's fine. Just to make this a little more visual. Okay. One of the main things that I see students every year get confused on is, what is the y-axis, what is the x-axis? Okay, so this vertical line here, okay, highlight that. This is your y-axis. It's your y-axis. Okay, it's the vertical line. So as you go up and down this line and count numbers, that's referring to your y value or y values. Your x-axis is obviously the horizontal one. Okay. And this we're just labeling, just as a refresher. Hopefully this is all very, very familiar stuff for you guys. I know we haven't done graphing the first semester, but hopefully seeing this is just a big refresher. Now, each of these 4 are called quadrants. This is quadrant 1, this is quadrant 2, quadrant 3, and quadrant 4. Let's talk about the values that we'll see for x and y. Now remember, your coordinate system is always as x, comma, y. Okay? In this first quadrant, though, what are the values of x, positive or negative? Let's think of a number line. If this right here is 0, this is 0, 0, all of my x values in this first quadrant are going to be positive, right? All of my y values, let's imagine that this going up would be positive, this going down would be negative on a number line. So everything in quadrant 1 is going to have what value for y? Positive or negative? Positive. Very good. Okay. As you get to quadrant 2, let's do our x's first. On the number line, if this is 0, everything on the left is 0 is going to be positive or negative? Negative. So these are negative x values. Our y values, though, are what? Positive. Very good. Okay. Bottom quadrants. Quadrant 3. Okay. What is our x values going to be if it's left of that 0? Negative x. What about our y? This is 0. What's going down from 0? Okay, very good. And then quadrant 4, what values of x do I have? Positive. And then y values are negative. Okay. Hopefully that was just a review. Okay. I know that seems very basic to go over, but I felt it was necessary just to kind of remind you guys what values, because every year I have students that mix those up. Okay, go over to the page 4 here. Now, what we're going to do on this page is we're going to graph the example from page 2. Okay, the y equals, I believe it was 3x. 3x minus 4. So what I'm going to do is I'm going to list the xy coordinates here real quick for you, and you can copy those down. We get -2, -10, -1, -7, 0, -4, 1, -1, and then we have 2, 2. Okay, those are the values. And what we're going to do is we are going to plot them on our number line. So the first one, -2, -10. The x-axis is -2, so from 0 we're going to count back 2 places. Okay, y is -10, so we're going to count down 10 spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, we're going to run off the graph on this one. You can kind of estimate. If it was more than just that one point, I would probably tell you to make each of these lines a different value. Okay, for right now, we can assume that each of these values represents a unit of 1. So this is the first one. I'm going to go ahead and label this -2, -10. Okay. Second one, -1, -7. So we're going to go from the x-axis over to the left 1 and then down 7 places. 1, 2, 3, 4, 5, 6, 7. Draw a circle. Go ahead and label it. Okay, next one, 0, -4. So x-axis is in the middle. We're going to count down the y-axis. 1, 2, 3, 4. Draw a circle, label it. You won't have to label points on all of these, but since this is our notes packet, go ahead and label so you can have something to refer back to. 2 more points, 1 and -1. So my x-axis is 1, and then I need to go down 1 on the y-axis. Last but not least, 2, so I'm going to go over on the x-axis 2, and then up 2 on my y-axis. And you can clearly see that all of these points do form a line. Now, grab a straight edge of some sort. If you have a ruler, that's fine. You can do a sheet of paper. What I want you to do is you are going to connect these dots. And this is one thing on graphing in your homework. You're going to be graphing on graph paper. Okay, I expect your graphs to be nice, very clean. There's no reason to have sloppy graphs. So grab a straight edge. It could be the edge of your paper, the edge of your interactive notebook, something that's, you can draw a line. I will say that you do need to put the arrowheads on your graph points because technically, are these the only 5 points that are included? No. This graph can go on forever. Okay. Questions so far? Okay, so what we're going to do is go to the next page, example page 5. Now, this one you're going to do on your own, okay? So just like the last example we did. Okay, so this next set, we know how to plug in values for our equation. This set right here is going to be specifically graphing linear equations by locating the x and the y intercepts. Which makes it really easy because all you're doing is solving for 2 points. You're graphing those, you can make up a line. Now, conceptually though, every year students confuse what the x and the y intercept are. So let's focus on the x-intercept here real quick. The x-intercept is the point where the graph crosses the x-axis. Remember, it's that horizontal line. So it's wherever it crosses that horizontal line. X-intercepts happen when the y-coordinate, okay, or you can think of the y value in your coordinate, is 0. Okay, so in order to cross that x-axis, y has to be 0. So to find the x-intercept from an equation, replace y with 0 and solve for x. That easy. Okay. Plug 0 in for y, solve for x, just like you would from the first unit that we worked. Okay, that'll give you the x-intercept. Now, up here up top, I want you to put what that coordinate will look like. X comma 0. So whatever you get as your x value, you'll plug in, and that will be your coordinate. Y is 0. Your value will be x. You would plot that on the x-axis. Okay, same thing with y-intercept, except the y-intercept is the point where it crosses the y-axis. Y-intercepts happen when the x-coordinate, or x value, is 0. So just like we did in the x-intercept, what do you think we're going to be doing in the y-intercept? What are we plugging in, or what are we replacing? We're replacing x with 0 and solving for y. Okay? And so what do you think those coordinates would look like? If x is 0, 0 comma, and then whatever your y value is. Okay? Very, very simple. So let's do one of those examples. Let me know if I go too fast. I'll be more than happy to slow down. Okay. Okay, so this first one, what you're going to be doing is you're going to be doing two different sets of work. So I'm going to draw a line, and what we're going to do is graph 3x minus 2y equals 12 by finding the x and y intercepts. So over here on this left one, I want to find when x is 0, I want to solve for my y-intercept. Okay, and so I'm going to take my original equation. Now I like to rewrite things, but I know that some of you don't like to write. So what you're going to do is take the equation, you're going to plug 0 in for x. This is the portion where you have to show me work. Now, what makes this easy is, what is 3 times 0? So you can just cross through that and kind of ignore it from this point. What you have left is negative 2y equals 12. And so solving for y, divide off my negative 2. Y equals what? Negative 6. And so I can set, and I can write an ordered pair. X is 0, y is negative 6. We'll plot it here in a minute. Okay. Do the same thing to find your x-intercept, except now we're setting y equal to 0. Okay, we're going to use the same equation. We're going to plug in our value for y. What is negative 2 times 0? 0. So I'm just going to cross that out. What I have left is 3x equals 12. Divide off my 3. X is equal to 4. So I'm going to write an ordered pair. X is 4. Y is 0. Now I have my two x and y intercepts. I can plot those. Okay? So the first point, 0, negative 6. My x-axis is 0. So I'm going to start here. I'm going to go down 6. 1, 2, 3, 4, 5, 6. Draw a little circle. Okay, that's my y-intercept. Plot the 4, 0. X-axis, 1, 2, 3, 4. Got my 2 points, take my straight edge, connect the dots. Sorry. Okay. Draw your little arrowheads and your things, and that's your graph. Now, for your notes purposes, what I want you to do is label this. You will not have to label this on your homework. X-intercept is right there. This is my y-intercept. Okay, just label it for your notes purposes, but like I said, on your homework, you do not have to. Okie dokie. So what I want you to do is use the same concept. I want you to do example 4 on your own, and we will compare answers. Now this will be the start of a new page in your interactive notebook. You can see it's page 1. Graphing lines that pass through the origin, vertical lines, and horizontal lines. So what is the standard form of equation? Now, I would like everybody to highlight this question or underline it because this will be a question on a quiz and a test. What is the standard form of an equation? Standard form is in this format. AX plus BY equals C. Okay? Your A, B, and C represent numerical coefficients. So any number value. Your X and Y obviously represent your X and Y terms. So let's imagine this. If C equals 0, okay, the equation can be rearranged in the format of Y equals a number, an expression, okay? And the x-intercept and the y-intercept are both 0, 0. So if you have a graph or an expression or an equation that's in this format, okay, y equals x. Now you can have numerical values in front of those, that's fine. Your origin, your graph will go through the origin, 0, 0. Those are your x and y intercepts, okay? So 0, 0 represents the origin of a coordinate plane. Now remember, you can have a number in front of those, it's fine. Okay, so let's go over to this page 2, and let's graph y equals 2x. Now let's test this theory. We know that we can pick out some points for x, plug it in, get a y value, and get a set of coordinate pairs. So let's do that real quick. We're going to just pick 1 negative, 0, and 1 positive. So I'm going to do 2. So negative 2, 0, and 2. Let's plug this in and see if this graph does go through the origin. Let me darken this up just a little for you guys. Everybody see that? Okay. So if we were to plug in negative 2 for x, what is our y value that we get? Negative 4. And so we can write a pair of x, y coordinate pairs. This is negative 2, negative 4. Let's plug in 0. Y equals 2 times 0. 0. There's our origin right there. And then y equals 2 times positive 2, which equals positive 4. Okay, now do you always have to pick the same positive and negative values? No, you don't. I just did it just out of habit. So let's plot these 3 points. First one is negative 2, negative 4. So I'm going to count over on the x-axis 2 places. Go down 4. 1, 2, 3, 4. Okay, and my next one is 0, 0. So that's my origin. That's right there in the middle. And then 2, 4. X-axis I'm going to count over 2 places. 1, 2, 3, 4. I'm going to count up 4. And then you can see that is a linear equation. I'm going to connect my dots. Okay. Very simple. Now I'm going to make, since this is notes, I don't know, I didn't spell that right. That is your origin. That's your 0, 0. Okay. Now, the next page, you are going to see a foldable. And to make this foldable easy, what I want you to do is go ahead and pull this page out. So you're gonna end up tearing that corner. That's okay. Okay. And we're gonna go ahead and cut this out right now. So we're gonna take some time. What I want you to do is only cut the outside box. I'm gonna highlight this so that you can see very, very easy what you're gonna cut. Right now, you're just going to cut this outside box out. You can throw away all the excess paper that you have. Okay? I'm going to highlight the portions that I want you to cut now. Okay, because you're not going to cut every line. This is very, very important. So on this top layer, you're going to end up cutting this line here and this line here, and it's going to create little flappies. Okay? And then you're going to cut this line, and this line. Okay? So you're going to cut in those parts that I have shaded, This part you don't want to cut, and then this part here you don't want to cut. You only want to cut down to that middle line. Okay. By doing that, we've made several little flaps. Okay. And what you can do is you can fold this flap in, crease it, fold this flap in, crease it, fold this flap in, crease it. Okay, and we've got little booklets. Then we're going to take this inside layer that we cut and fold that in. Okay. And so now we get a little foldable that looks like this. And because I like color, I'm going to use highlighters, but you can use whatever you want. I'm trying to get this a little darker so you can see it. Okay, now, any questions on the foldable board? Does anybody need help with that? Is that too dark for you guys? Okay, so you can see that I already have something pre-labeled. So this is for vertical and horizontal lines. Every year I've got students that still flip-flop graphing horizontal and vertical lines. Now, this is when y equals a number. Your x value will not be present in this type of example. So this is like saying y equals 1 or y equals -7. If y equals a number, you're going to use these 3 boxes to help determine how do I graph it. Is it vertical? Is it horizontal? And so on. So what I'm going to do is give you a little acronym, and that is HOY. So H-O-Y. And I'm going to, whatever, if you're using pen or highlighter, I'm going to highlight that in the same color so that I know that those go together. Like I said, I don't care if you use it, but I like color. So H-O-Y, HOY. And so what that represents, or what that stands for, I'm going to flip up my H, is that the line will be horizontal. Okay? The line will be horizontal. And let me see if I can darken that up for you guys. Is that too dark? Or is that better? Now, let's make sure everybody knows what horizontal is. Okay? And if you can't figure out already, horizontal is in this direction. That's why we did the HOY on top. So it's left to right. So your line is going to be left to right on your graph. Okay. Now, we haven't discussed slope yet, and we will get to that in section 7.3. But horizontal lines have 0 slope. So your slope would be equal to 0. That's where you get the O. It looks like a 0. Okay? So horizontal lines have 0 slope. And then the Y is to remind you that the line will cross the Y axis. Okay, remember that Y axis is up and down, so my line is going to go through the Y axis. It's horizontal. Okay, so H-O-Y. Help that let you remember that when Y equals a number, think horizontal, think 0 slope. It's going to cross the Y-axis. Any of those you need me to keep open or repeat? Now, the next one, okay, we're going to talk about what happens when I get a graph that has x equal to a number. Okay, and I'm going to use a different color, but you don't have to, but I like color. Okay, and mine's going to be purple. I know it kind of blocked it out on your screen, but when x equals a number, I want you to remember the acronym VUX. V-U-X. X. Okay, VUX. And so just like we did with Hoy, we're going to write little reminders. V, what do you think the V stands for? The line is vertical. Very good. And that's up and down. So we're going to have an up and down graph. It's a straight line. U, now like I said, we haven't talked about slope yet. I'm so sorry that I'm not getting good at these. Brightness. U, we haven't talked about slope, but the slope for vertical lines, so vertical lines have undefined slope. Okay, and I do want you to highlight that word, undefined. It'll come in handy when we get to section 7.3. I'm horrible at this lettering today. I apologize. Okay. Undefined slope. And then X, my last box, the line will cross the x-axis. Okay, so remember, the x-axis is the horizontal line. Our line is going to be vertical and cross through the x-axis. Okay, now this right here we're going to put aside. This is going to go on page 8 in your notebook. Page 8. And we'll spend some time here in a minute because we're going to do 2 more examples that are really simple. On these 2, we're just going to practice graphing these. Okay, and remember the acronym HOY and VUX. HOY and VUX. Okay, so on example 2, we have a graph that's x equals a number. X equal number. So are we going to look at HOY or are we going to look at VUX? VUX. Okay, and if you ever forget, look, it ends in the acronym that you need. So what this means, that I know my line is going to be vertical, and I'm just going to make some notes. You don't have to do this on every single problem, but what I want you to think when you see this is vertical line, okay, and undefined slope. Okay, vertical line, undefined slope. So if x equals 2, we're going to go to our x-axis. We're going to go over 2 places. We're going to draw a dot. And since I know my line is going to be vertical, it's going to follow along up and down. That's my graph. Okay, now I'm going to highlight this because I want you to be able to see it very good. You don't have to highlight it on yours, but unless you want to. Okay, it's a vertical graph. This is an x equals 2 graph. Very simple. Okay, the hardest part is you remembering which way it goes. Okay, last example. Example 3, y equals -3. Okay, so y equals a number. Do I want to think of HOY or VUX? HOY. And what this should remind you is horizontal line and 0 slope. Okay, and so if y equals -3, I'm going to go to my y-axis. I'm going to go down 3, draw my dot, and since I know that my line is going to be horizontal, I draw the points. And that's it. Okay. Now, we still have some pages of this notes packet